Hello everyone, this is Bradley Sward, and this video today is 2022 Advent of Code Day 9's puzzle, at least part 1 here. I'm just thinking about part 2 right now. This problem is called Rope Bridge, of course. And so we basically have the idea of a rope being moved around and the tail is, coming from, behind, kind of like you would expect from a game of Snake or something like that. And there are some rules for this. And so as the head moves around, the tail basically tries to follow. And the rules are kind of like if it's in a cardinal direction, if it's 2 units away, you move toward it in either of the 4 different directions. And otherwise, if it's basically like a chess piece, or I'm sorry, like a chess piece, if it's like a knight on a chessboard, any of those 8 positions, then you would move diagonally toward the thing. And so there's basically 12 different movements that the tail can make, or I guess technically 13 if it doesn't move at all. And basically the question is, as this head moves around in a specific pattern, how many of the different squares does the tail touch? And so in this case, it comes out to be 13 with this data set. This was a 13er, and it shows you all the things. And so the question was, with a larger data set, how does this all work out? And I pretty much hard-coded the movements. I pulled in the file, kind of as normal here, so I get a list of lists. And basically, I'm starting from the 0 position, so I'm keeping track of that, but by using lists for the head and the tail. And I'm going to keep a set for the locations, because if I hit a location more than one time, I don't want it to be added a second time into my set. And so by keeping adding the tail positions as I move along, basically the size of this thing will basically be how many of the different unique squares have been touched. And so I set up a little map for each of the 4 different directions. Down goes 0, 1, and you can see for the rest. And then basically this tells you how many times I want to move in that specific direction. So it's a loop structure based off of that number for each individual line. And then basically I just move that many times in that direction, and then figure out what the dx dy is. And again, if it's 2 units away in any of the 4 cardinal directions, I just move toward it. And if it's a chess piece for any of the other 8, it's 2 of one and 1 of the other in negatives and positives, just making sure that everything kind of works out and you have the right negatives and the right positives in the right places for the 8 positions. But every time I move this piece, the tail, then I want to add that tuple, or basically add that location to my set. And I just do this over and over and over and over again. And then when it's all said and done, I run my program here with my part 1 solution coming out. The length comes out to 5,981, which just happens to cover, oh, there it is down here, 5,981. So there's my solution to part 1. I'm going to start looking into part 2. It looks a little more complicated. Maybe it's not. And if so, maybe tonight I will post a video for a solution if I come up with it. Otherwise, it probably will be either sometime tomorrow or who knows when. So thanks everybody for sticking it out with me as always. Have a great night. Another fun puzzle. Have a good one, everybody. Take care. See you next time.